Hi everybody. Following the database migration that just Riyad has described, we started to use various projects around ClickHouse, and one of them that was very critical to us was Chproxy. And in this talk, we would like to share with you the details and our latest contributions about this project. But let us firstly present ourselves, because on the Zoom we are just a pizza. In fact, we are not pizza. We are. I'm Paweł, data engineer that works at Contentsquare for over 2.5 years. And since the very beginning of my journey at Contentsquare, I actually worked very closely with ClickHouse. And eventually I joined the team of Riyad, where we work closely on ClickHouse, even more closely. And this is François.
Hi, my name is François. I work as a data engineer at Contentsquare. I've been there for 2 weeks. So first of all, let's present ClickHouse at Contentsquare. So before anything, I will give some context about the kind of data we deal with at Contentsquare. So basically, we work with sessions and views. So a session is an aggregation of several views. So here on the left, you can find an example of some columns we store in ClickHouse. So a session number, a session time, a device ID, and so on and so on. So basically, all of this data is stored on a ClickHouse cluster. So for instance, here we have a 2-shard ClickHouse cluster. And basically, our workflows are mainly analytics query. So we perform aggregations on our data. So for instance, a typical query would be what is the average session duration for all the views for a specific date. So now let's imagine that we have the following ClickHouse cluster topology, where we have 4 shards, and each shard is replicated, and that we have 3 applications. Each application would like to retrieve some data, some metrics from ClickHouse. So as it is, each application would need to be aware of each shard if they wanted to implement round robin and spread the load on each shard. So basically, it means that if we were to add one more shard, we'd need to update every application to make them aware of the 5th shard. So basically, we need a proxy. A proxy would be a component in front of the ClickHouse cluster, and the proxy would be aware of all the shards that are present in the ClickHouse cluster. This way, our applications only need to know the proxy URL and don't have to be aware of any shards in the ClickHouse cluster. Also, if we add one more shard, we just need to update the ClickHouse proxy, to make it aware of the 5th shard without changing anything on the applications. So now that we explained the need of a proxy in front of ClickHouse, we will present ClickHouse proxy and give an overview of some features we use at Contentsquare. So a quick list before we dive into, we detail it a little bit more. So we use routing capabilities, load balancing, user management, caching, and some other features. So now let's imagine the following scenario where we have 3 applications, A, B, and C. The first one will need to query some data from the ClickHouse session cluster, while the 2 other applications, B and C, will need to get some user data. This data will be served through Chproxy. First of all, what we need to do is to define clusters. So here, for example, you can find an example of configuration where we create the ClickHouse session cluster. We specify that this cluster will have 2 sets of replica because we have 2 shards and 2 replica. And also, we specify the user to connect to ClickHouse. Finally, we also add a user section where we define 3 users, here, application A, B, and C. Each user has a password, so it will help them to authenticate to Chproxy. Once authenticated, the user will be mapped to a ClickHouse cluster and to a specific ClickHouse user. So for instance, here, application A will target ClickHouse session cluster and will use the read-only user to connect to ClickHouse when authenticated. So now, quick word about routing. So nothing fancy here, but basically, if application A sends a query to ClickHouse proxy, it will be forwarded to the correct cluster. And the same thing will happen for application B and application C that will be routed to the ClickHouse user cluster. ClickHouse proxy also implements load balancing. Let's imagine that application A makes a query. The query will be routed to a specific shard in the ClickHouse session cluster. And if application A executes a new query, Chproxy will probably robin the request to another shard in order to spread the load on the ClickHouse cluster. Oops, sorry. Now, we also have caching ClickHouse proxy. For instance, here, imagine that we add a disk cache to the user application A, where we say that the user application A will use the cache application A. A cache is defined by its name, an expiration date, an expiration for the values in the cache. Also a mode, for instance, here we say that the values will be stored in the file system, and also a parameter gracetime that I will explain a bit later. Now, for instance, let's imagine the following workflow where application A makes a query. The first thing that Chproxy will do is try to see is there anything in the cache for application A. There isn't, so I will forward the request to ClickHouse session cluster. After that, when I get a result back from ClickHouse, I will persist it in the cache and I will forward it to application A. Now, if application A executes the same query within the hour, the data will be served from the cache. Same stuff will happen for application B and C that share the same cache. Now, a fancy feature that comes with ClickHouse proxy is the concurrent caching mechanism. Let's imagine that we have the following scenario where two applications, so B and C, execute the exact same query at the exact same time. What will happen is that Chproxy, in order to save resources on our ClickHouse cluster, will only forward one of the queries. Now, two things may happen. If the query takes more time than the grace time, then after the 30 seconds, Chproxy will also forward the application C query to the ClickHouse user cluster. But if the first query took less than the grace time, then the result will be persisted to cache, and application C will get its result directly from the cache. So basically, it's a neat feature to save resources on our ClickHouse clusters. Okay, so now some more features that comes with Chproxy. First of all, we have query stripping that are basically useful for security reasons, where you don't want users to be able to pass ClickHouse settings in a query. We also are able to whitelist some IP ranges if we need to restrict access to ClickHouse proxy. And finally, we have two more parameters to add constraints on our users. For instance, we have the max concurrent queries parameter to tell something that like a user can only execute two queries at the same time, and also a query cannot exceed a max execution time seconds. So now that we've explained some features we use at Contentsquare in Chproxy, Paweł will give you a small history of Chproxy.
Maybe before going forward, I will just check the chat because I see there's many messages. But I think it's just a discussion. Okay. So yes, let me walk you through the history of the project. The inception of the project happened in 2017, where a company called Verdamedia created Chproxy. Because at the time, ClickHouse had some limitations related to control of the resources, such as max execution time was permitting sometimes to exceed the limit, and therefore the utilization of resources was higher, as well as the max concurrent queries was running on a node basis, so it was hard to control it on the cluster. And so, as François showed to you, the project evolved very much, and it has much more features. And big kudos for that to the Verdamedia. Whereas us in 2019, we decided to migrate ClickHouse we decided to migrate from Elasticsearch to ClickHouse. And from the day one on our production systems, we used also Chproxy. It served our needs very well along the way. We though saw that in 2020, more or less, Vertamedia started to drop support for the community version. They did no longer have time. But it didn't bother us because we had all the features that we needed at the time. Although on 2021, something changed that led us to choose different direction and take the ownership of Chproxy and invest in it in 2022. You may ask what's coming next, and so the target is an IPO in 2024. Yeah, but let's put the jokes aside and see what happened really in 2021. That year, we realized something. During one of our coffee breaks at the office, we discussed the optimizations of our ClickHouse cluster. So we decided that we will have a look into the resource utilization, various resource utilization metrics. And we happened to check the number of identical duplicated queries, which you can see on this slide. They are marked by blue surface, and this is the evolution over the day. Adding to that, the red surface accounts for the total amount of queries executed on one of our clusters. So clearly, we see here that during the working hours, there is many duplicated queries, roughly 25%. We continued our investigations, and we realized that the source of the problem is Chproxy. And in fact, it's the way we use it in Contentsquare. So to illustrate the problem, let's look at this scenario. We have the topology of two replicas of Chproxy, because in Contentsquare, we have the policy that for customer-facing applications, we need to have a high availability. At the time when we started using Chproxy, we had only a single replica. That's why there was no issue at the very beginning. But so let's illustrate the problem by replaying a sample query. Application sends the query to Chproxy. Chproxy looks up into its local file system cache if the result has been already computed. It wasn't, so Chproxy redirects the query to ClickHouse. It gets computed, and after all, flashed into the local cache and returned to the original application. But application decides again to replay the very same query. This time, though, it lands on the replica number 2, and Chproxy checks again in its local file system cache the existence of the item for the query, but unfortunately it's not there. So again, it hits the ClickHouse, and the computation is wasted because it's the second time the same computation. After all, it's also saved to its local file system cache. So we delved into Chproxy to see if we can improve the solution for this use case. And we decided to change the mechanism of caching and the fact to enrich it with extra functionality. And that's how we created the distributed cache in Chproxy. Let's have a look again at the former scenario, except that this scenario will be using distributed cache. So instead of having one cache per one replica, we will have one cache for a share across two replicas. And we will replay again the scenario. So application will send the query to replica 1. We will check in the cache if the item was already existing. It wasn't, so we compute it on ClickHouse cluster, save it to the cache, and return the final answer to the application. Application again sends the identical query to the replica number 2, but this time the replica number 2 finds the result already in the cache, and so we save the computation power. And this was great. We delved into this code, we implemented it and tested, delivered it to production, and we wanted to observe the results, which are here. And as you can see, this is the same graph that I showed just before, except that the blue surface is completely gone, which is exactly what we wanted. So we are very satisfied. But you know what? It's not yet the best. The best is that you can use it also on your systems, and how to use it is showed here. Depending on your scenario, if you are also in the case where you have multiple replicas, you might be interested in using distributed cache. Currently, it's implemented with Redis, so you will have to have the Redis instance up and running, to which your Chproxy would connect to. The definition of this connection is also configuration based, and it belongs to the definition of the cache. But maybe you are in the scenario where you have only one replica, and you better stick to the file system cache, where the definition you can find here. So I've been talking about file system and Redis, but in fact you might be interested in a different kinds of integrations. And you know what? You could do that. You could help us actually, because when we were building this feature, we did our best to design it in an extendable way. So what you would have to do is implementing this interface and additionally configuration to potentially, I don't know, adding Aerospike as another key value store, because maybe in your company you have the policy to use only Aerospike. Who knows? So we would be very happy to help you to do it with this endeavor. All right, so we discussed, we presented to you the overview of the Chproxy, the brief history, and the future. And now it's time for the future, real future. So here is our roadmap for 2022. We want to focus on three following dimensions: on the reliability by actively handling the reported bugs, issues, by adding the CI operations improvements, such as provisioning Docker images and doing the code audit. We also want to make the access to Chproxy easier. And for that, we are bootstrapping the website with the documentation. And de facto, we did it already today. The website is already on. And later on, we will probably add the tutorials for different scenarios. And last but not least, we want to invest in innovation and supporting innovation, one of which could be a distributed rate limiting, and another one is yet to be found, perhaps by you. So feel free to reach out. And so that's it from us. Summing up, Chproxy has been on Contentsquare production for a long time. It served very well our needs, and feel free to check it out. I will check the chat.
Yeah, there's a few questions in there now.
Yeah, and please read the question before answering.
Yes. Questions, Chproxy. In a multi-tenant environment, is it possible to call an API to configure a new tenant? Yes, it is possible. You have actually a feature in Chproxy that is interesting. You can reload the configuration without downtime. This might be also something that you would consider then. We also want to add a query cache to ClickHouse itself. Okay, this is not a question. Question, for security reason, is the cache splitted by Chproxy user, company tenants? So yes and no. Depending on the cache you use, file system cache is split by user, whereas the distributed cache currently is shared. Then to the Guillaume's question. Otherwise, user setting can affect query results for identity looking queries. I think I missed the first question. Yes,
It is the same about security when multiple users are doing the same query, but they still can get different results due to some access control restrictions, and it will be insecure to cache the result for one user and output this result for another user.
I see the point, yes. Question, how the result is cached in Redis? I mean, how the tabular data mapped into Redis key value store? So the key of the cache is basically a query along with some metadata of the request, whereas the value is simply a raw byte stream from ClickHouse. It supported both the encoded, compressed stream as well as raw data, non-compressed. For which use cases don't you recommend ClickHouse? Maybe this is for Alexei.
I don't recommend to use ClickHouse as transactional database for your company, operational database. I don't recommend it as a replacement for Redis, but for every analytical use case, I do recommend ClickHouse. But this question is actually for you. Everybody already knows my answer. But I'm interested about your experience in Contentsquare. Is there some bad experience with ClickHouse when you try it and it works not quite well?
Yeah, we actually had problems at the time, especially with the upgrades of the schema, where we didn't have yet a lot of experience. While doing the schema upgrades, so altering or adding some column, for instance, if we didn't check beforehand that all the processes and mutations were well finished, it was causing a deadlock, and the problems were becoming bigger. So because we were doing a change on the schema and there was data being inserted at the same time, internally there was a problem. That's something that I think of.
Quite interesting. By the way, what version of ClickHouse do you use today?
It's the 2021.3. Most of the issues were with the 2020 version of ClickHouse, I think 2020.3. I think that you would see diminishing returns if you have many updates and deletes on your data set. These are heavy. So if your workload, if most of your data is immutable and you have a very small portion of it that needs updates, you can find a way to work your way around it, and you can still benefit from all the power that ClickHouse brings to the table. But if you have if you have to deal with a lot of deletes, a lot of updates, and you have to deal with a lot of mutability in your data set, then it becomes a bit more cumbersome to operate, and you see diminishing returns with the technology, in my opinion.
Okay, thank you. And a question about Chproxy and caching. So if you have some query with enormously large result, would this result be cached? And what about cache pollution of this large result?
Yes, it's a very right question. Currently, this would be a problem because it's not handled. It's though it was added to the list of improvements. So it would cause problems.
Okay. I hope it will land into Chproxy soon. Otherwise, we are going to implement our own caching layer inside ClickHouse. What do you think about this perspective?
Would it be a cluster-wide caching?
Most likely not. Most likely it will be on every node, so it can duplicate some caching results if queries will be processed on different nodes. But there are many possibilities, like if you have some query with order by something, limit 10, and the next query the same, but limit 10, offset 10. Can it somehow reuse the result of previous query? It is not so easy, because for this purpose, we will have to cache intermediate data. But it can be quite interesting.
Yes, but the advantage, though, would be also with Chproxy that you do not have to open a connection to ClickHouse if the data is already cached in Chproxy.
Okay. So even if you turn down ClickHouse, some queries will be still served.
Sorry, could you repeat?
If you turn off ClickHouse server, do I understand that some queries will be still served for 30 seconds?
Yeah, they will be served for as long as Chproxy is up, obviously, and as long as the query has been already cached.